Myth 2. Research software should be given to software experts to sustain it. This is also something that gained prominence not just in the sort of research arena, but also in the industrial software arena over the last 10 or 15 years. There was this idea that it was the right thing to do to take things and segment them, because then you could make sure that the people with the right expertise could always work on the bits that they were experts in. However, some things are best kept together. Things work better in partnership. And what we found as we've moved on is that this isn't always the case. Software experts, strangely enough, are important in the sustaining of research software, but they're not necessarily the only thing. And just in the same way that, as I'll go on to show, we've changed in our thinking about software development models. So the question is really about, can we throw things over the wall? Because what we see when we do things like the interviews that were done in the Engage project that I was involved in, is that people do talk about sustainability. People know that it's important, they know that they want it, but it's not always clear who should do it. So we get things like, sustainability is not an issue for researchers, we want others to take on the software, subject to things like IP. You get others who say, sustainability is a big issue. We are creating complex tools that we want to continue to use, but it's not clear how they'll be sustained. And this message is repeated, whether they are researchers who aren't developing software, whether they are researchers who are developing software, whether they are external software companies, software development groups, and so on. Everyone is thinking about sustainability just now, but everyone is really thinking that someone else should be doing it. And there's this idea that you can just throw something over the wall, like you do in software testing, where it bounces between two teams who sign it off. The problem with that is that it creates an artificial divide. It creates a lack of trust, and it creates, really, it breaks down the ability to do things better because you're working in a team. So this is something that's also been looked at in terms of software development models, and where we started off by looking at things such as waterfall models, and then moved on to things like spiral development and so on. A lot of what we've gone from in the software engineering point of view has moved from very rigid models of development to more agile models of development, things like Scrum. And one of the things that they place an emphasis on is working together in small teams, understanding how to efficiently make decisions. And it's the same thing when you look at any sort of software. If you don't understand who should be involved in the maintenance and sustainability of software, you can't do the sustaining of software. One example of a company that lost its way in terms of the overall sustainability of its software because it lost sight of what keeps it current, what keeps it important, was Netscape. This is particularly interesting for me because Netscape came around when I first really started using the web at university, using it for research. And Netscape went through many different versions. Indeed, when you look at too fast. When you look at the sort of rise and fall of Netscape, see if it works. No. What you'll see is that it went from very, very small beginnings up to the point where it had almost 80% of the browser market, and then it went into a decline. So why did it go into a decline? Well, it forgot that a piece of software is only good as long as it retains a link to the community of people that use it. One of the things that in the histories that have been written about Netscape that caused its downfall is the fact that it diversified into a set of products that didn't really suit who the company was aiming its software at. So it started doing things to do with business portals. It started looking at office suites. It became a company that was all about everything and also produced a browser. So it lost sight of where it was going. It also fought against Microsoft, which is something which a lot of research software ends up doing, and sometimes losing. But in losing its connection, losing the idea about what created the spark of the community that built up around the software, it also lost its way. And I think one of the things that's noticeable is that you've got to be able to understand who your community are and make sure that there is a connection so that you're truly working together. And I think one of the things that's become clear is that just as in agile software development, you want to make sure you have small teams, making sure that you have both your customers and your developers, your providers and your users together. That's exactly the same with research software. So a better example is something like CASTEP. So CASTEP has had a long path and a long journey, starting off as a code that was developed by an individual, going on to be maintained by a group primarily based in one area in Cambridge, into a consortium that brought together people from different universities across the UK, starting to work with industry rather than against industry, and understanding how to make sure that it always met the needs of its community. So understanding when, for instance, they needed to change the user interface, understanding at what point they needed to change the models that they were using. I think one of the key things that has contributed to the success of CASTEP is that you've maintained this link with the academic community that gave birth to the software. So now you have a piece of software which is being developed both by academic developers and by industry developers. And together, that software is stronger and continues to be active. So what's myth 3? Myth 3. I can program, I can look after it. And this is something I often say to myself when I try and develop some Perl script for some web pages or something. This is an interesting question. So how many of you would consider yourself to be software developers? How many people would consider yourself to be researchers? How many would consider yourself to be both? Okay. Here's a question then. How many of you would reckon that you've had more than, say, 10 years training in software engineering and you are a researcher? Malcolm. One of the problems is that a little knowledge is a dangerous thing. And I think one of the things that I've noticed when talking to lots of different researchers across the country is that there is a huge variation in the amount of training that's given in terms of software engineering as opposed to programming. So this is almost the flip side of the last myth. In the last myth, there was this idea that you could give software to experts and they could just go away and look after it. And I hope what I managed to show said that you still need to retain the link with the community that the software came from. The ownership has to be in that community. But you still do need software experts to bring in their skills and experience. Because on the other side, there is a problem in that you can end up with a set of people who think that they are the right people to take on a particular task, but actually don't have the training to do it. As a quick comparison, it's interesting to note that the career routes for software architects and for head chefs, executive chefs, have very similar parallels. It takes you about 3 or 4 years to train to be a chef. It takes you about 3 or 4 years to train to be a software engineer. If you're good, you'd expect to make architect or head chef level in about 10 years.